Alright, so this is a progress video, and here is a non-completed pre-quiz, and here's the pre-quiz that I did earlier today. So what I did is I marked the questions that I got completely wrong or didn't understand in the purple, and then I marked questions that I almost completely understood but got parts wrong in the orange. Just 3 of those. So I'm just going to go through and do each problem to see if I can get them right. So for this one, find the equation to a line in slope-intercept that goes through the points -5, 2, and 6, 7. The first thing we're going to want to do is we're going to want to find the slope. So we do that with the equation y2 minus y1 over x2 minus x1. So all we have to do is plug the points in. So we come up with 7 minus 2 over 6 minus positive 5, which is going, 6 minus negative 5, which is going to be plus positive 5 there. All we'd have to do is simplify that, so we end up with 5 over 11. So that is going to be our slope. And then all we have to do is choose one of these line points here and then plug it in right here. So we do that with the slope-intercept form, and that is going to be y minus y1 equals mx minus x1. So just to plug that in there, y minus, we're going to go with this point here. Actually, we're going to go with this point because they're both positive. So y minus 7 equals m, just substitute the slope, so 5 over 11, x minus 6. So then all we have to do is distribute the 5 over 11 in here, and then we can drop that parentheses as well. So y minus 7 equals 5 over 11x. And then I'm just going to do it on my calculator to do 5 over 11 times negative 6. And we're just going to put that in fraction form, so math fraction, and come up with negative 30 over 11. We're going to add 7 over, so I'm just going to continue this on my calculator, so plus 7. And I'm going to end up with y equals 5 over 11x plus 47 over 11. So there's our answer for that problem. And that matches my answer there. Number 2, find the equation to a line that goes through the point 3, negative 2, and is perpendicular to 3x minus 5y equals 10. So the first thing I'm going to do is I'm going to take this and I'm going to put it in y equals mx plus b form. So 3x minus 5y equals 10. I'm going to subtract this 3x over. So I end up with negative 5y equals, and I'm just going to put the x value right here so it looks more like the form that we're going for. It's going to be negative 3x plus 10. Just going to divide this by the negative 5 here. Negative 5. And I end up with y equals, because these are both negative, it's going to be positive 3 over 5. X, so there's our slope, minus 2. So then we have to find an equation that goes through this point that's perpendicular to that line. So all I'm going to do is I'm going to plug this again into this form up here, and I'm going to, hold on. Yep. I'm going to say y minus -2, which is going to be plus 2, equals, and then we have to find the slope, but remember that the slope is perpendicular, so we're just going to inverse these and put a negative sign in front of it. So it's going to be -5/3 x minus 3. And we're just going to distribute these into here, as we did in the problem above, and drop those parentheses. So y plus 2 equals -5/3x. And then we're just going to also distribute this into the -3 there. So do this on my calculator real quick. -5/3 times -3. And that's going to equal 5. So plus 5. Subtract the 2. And I end up with y equals -5/3x plus 3. And double checking with my other homework, that is the answer that I got there as well. So then for 3 and 4, we're going to use this equation here. And so all we're going to do is we're just going to plug the -4 in for the x values in these. And we're going to make sure that this value lines up with the restriction. So for this problem, x has to be greater than or equal to 0. And for this problem, x must be greater than 0. Or sorry, x must be less than or equal to 0. X must be greater than 0. So number 3, find the function g of -4. So since -4 is a negative number, it can only be applied to the first function here. 3, plug that in for x, plus 5. So our answer here, so it's going to be -12 plus 5 equals -7 here. So x equals -7. And then we can't use this equation because -4 is not greater than 0. Box that up there. And then for number 4, find g of 12. So 12, since it's a positive number, can only be plugged into this equation because x must be greater than 0, and here x must be less than or equal to 0, and 12 is a positive number, so it does not fit that requirement. So x squared, so 12 squared plus 1, and 12 squared is 144, plus 1 is going to be 145, so x equals 145. And there we go. And then this, for the following 3 problems, we have to find the domain of the following. So, for this one, area equals pi times radius squared. And we know from previous math classes that pi times radius squared is the equation for a circle, for finding the area of a circle. So, thinking of a circle, thinking of the radius of the circle, this value cannot be a negative because then no circle would exist, and it cannot be 0 because again, no circle would exist. So we know that for this one, x must be greater than or equal, x must be greater than 0 because you can have a radius of 0.001, but you cannot have a radius of 0. For number 6, find function of x, 2 over x squared minus 9. And we know that in the denominator of a problem, it cannot be, the answer cannot equal 0. So it cannot equal, this cannot equal 0. So x squared minus 9 cannot equal 0. So we know that if I, and to find 9, to find the square root of, or to find the square root of 9, it's going to be 3. So if I do 3 squared that equals 9. 9 minus 9 equals 0, so that we can't have that. So x cannot be positive 3. But we also know that since it's being squared, negative 3 times negative 3 also equals positive 9, and positive 9 minus 9 also equals 0. So y cannot equal plus or minus 3. Then for the final equation here, we know that 4 minus x cannot be a negative. So if it cannot be a negative, 4 minus 0. We know that this cannot equal a negative. Therefore, 4 minus 4 is 0. So we know that x must be greater than or equal to positive 4. Alright, so for problems 8 through 15, I'm going to graph this equation right here on my calculator. So we're going to do negative x to the third power plus 4x squared minus 5. So I'm just going to graph that here. Oh, sorry, I graphed it in the wrong plot. So it's negative x to the third power plus 4x squared minus 5. That looks better. Okay. So now that I have the graph on my screen, I'm just going to take my cursor and I'm going to find my points. So right here looks to be 0, negative 5, 2. So I'll put it out there. And then that appears to be x equals negative 1. Looks to be about a half. And 5 up. And to the right about 2.5. 2.5. Yeah, 2 about there. Just gonna, and then this up here seems to be right about there. And then just finishing this curve at about 3.5. And that one's going to go down to about there. So I'm just going to sketch this out. Alright, so now that I've sketched out my graph, to find the relative maximum, I'm going to go second, trace, then I'm going to go to the maximum, pick my left boundary